Howdy folks, and welcome to Alwa's NES Awakening. This is stream number 8. My name is Paul. I go by InfiniteNesLives online, and we are porting a fan port of Alwa's Awakening to the NES. Last time we we converted Tiled's output from Lua to binary bit-packed attribute table format so that we could have colors on our test screen here from Tiled. We started working on some assembly, and we didn't get very far. So we're gonna give that an honest effort today. I don't know how well it's gonna go, but I want to play around with assembly more before I kind of decide that I'm not gonna go with C. I haven't fully decided yet. So we're using Brad Smith's ca65 example. And I was having issues with the debugger scripts. I tested around some stuff offline. But I didn't actually get everything working, so let's oh yeah, I don't have Python installed on this computer, but we shouldn't actually need it because we got the ca60. I think the Python's just used to create the debugging symbols for FCUX, and this example.debug file is what mesen should like. So this one was just built. It works. I thought we broke it. Oh, I made a fresh copy. So this is a fresh copy. Oh, look at that. All the symbols are already there. So it looks like it is working, and maybe I just didn't know what I was doing. Because maybe I didn't look in the right spot. If I go import labels, example debug, see this says 0 labels imported, and now everything's just like gone, I guess. I don't. So it's weird to me, but it automatically loaded the right one. We just go tools, debugger. See, it's not there now. There's an auto load. Okay, so if auto load is selected when we launch the debugger, I don't know what the deal is. So Ben Chuck is giving us some tips here. Yeah. Seems to not. I don't know how I got that to work. That I didn't do anything. Yeah, and it is. I can't. But the thing is I can't even auto load it. I go, the weird thing is I load this example.debug. My program is called example.nes. This is example.debug. If I load this, it says 0 labels imported, and all of my code disappeared. Like, it doesn't even have the disassembly anymore. And I was looking at the, so let's do this. I have this old build of Brad's that seemed to be working. I wasn't expecting that to work temporarily just now. Anyway. So I've got this one that I was doing some stuff a while back. And it's got this annoying test tone at boot. Here, file, import labels, example debug. And that's where we were just operating out of. This one's out of. This is the same folder, 142 imported. In the saying the format is, yeah, and these, for whatever reason, these debug files look different, and so I was gonna try to figure this out, or just start here. So I don't really like the bat file. I want to make my own little makefile, but okay. So it's doing well. I'm gonna build this one over again, and this one's .nes.debug, but I was playing around with that off stream and it didn't seem to matter. Yeah, it just loads up because we've got auto load debug files, but if I import labels, we just compiled it. 142 labels imported, it works. So the build steps here. I'll link it, compile it, and then link it. So ca65. I have a Okay. And then link it. Yeah, ASM6 creates a different format, and then I think FCUX requires a certain format, and that's what I think he's using the Fox's script or something like that to create ones. I'm not speaking from much experience on any of this, just brief looking up on the discussions on NESDev. Okay, so it looks like I made everything manually. Yeah. From this other one. Seems to be doing the same thing. I wonder if my ca65 versions are the same. I think it's going to tell me what version is. Yeah, and in my old version that I downloaded from Brad's GitHub a long time ago, it works. In the newest one I just downloaded, I tried downloading a fresh one and it doesn't. So I don't know, it's broken. I'm just gonna try to use my version that does work, and maybe I can figure it out, and if I'm figure out what I'm doing wrong, or yeah. Well, and it loaded that one time, but I wonder if it was because I happened to have previously loaded the labels from the other project that was working. Because here's the thing that I noticed is if you look at this debug file, here's the current debug file that I'm having issues with. Here is the debug file that works. it's got all these line IDs, spans, sending it to other files, I guess. And so that none of that's there. It starts off with segment OAM. So the debug files are different. So I'm just going to copy this over. It's the metal one with the beep. And then this is the one we're working on. Yeah. So I don't know what's broken exactly, but this old version I have seems to be working, and I think I'm just going to go with it for now. And if I can figure out why, then I'll fix my issue, or if it happens to be there's no ca65. Maybe that this other one. Oh, I have to go down a directory and run ca65. Because in my NES folder, I have a cc65. Oh, and there's other things in here that are not. Maybe my cc65 is. Because here's the cc65 that I was using. It's got different stuff in here. Looks like it is a different version. So maybe that's the issue. I'm just going to copy this one. Maybe I was running an old version of cc65 or something. Yeah, this bat is. Let's remove this. Some background talking, but I don't know what it is. Okay. Can't find those files because I don't have them in there. I think my computer upstairs is running Twitch or something. Forsaken Valley. Forsaken Valley CHR. And in my copy these. Okay. Looks like it worked. $9.30. Why not? What is going on? Yeah, report that problem, Microsoft. Come on now. This is the file we just made. All right. So we got it. I wonder if we copy this, copy. Like how. Okay. It's all very interesting stuff. Let's see. Is that just CC65? Yeah. Looks like it was it. I thought that was relatively new. Not 100% sure where I stole that from, but I think I downloaded that version of CC65. I think I took it from my presentation project, which was this download this fall in this version. So it might, maybe the new CC65 doesn't work, or CA65. I'm not going to worry about which is which, but that was my problem. So we had all kinds of bugs in my assembly. So my root, I'm trying to change the setup background routine to what Brad's code had been doing was just clearing it and then creating a checkerboard. There was no actual import of name table or attribute table data. It was just manually creating the backgrounds. So I want to import from the file and the background. So I have Forsaken Valley CHR, we got build again. All right. Internet was saying. This one we just made. Set up background. I think I'm gonna, that whatever's going on upstairs is driving me crazy. I think I'm gonna run up there quick and turn it off. Fix that. So all of our data is here in the CHR viewer. Palettes not set up. Name table viewer. It's all cleared out. So I'm just never really played with. I'm not used to using debuggers. Just figure it out, but this seems to be pretty legit. So let's see if we can sort out how this works exactly. So we can hit F11. A currently equals 8. Can you, is this hex or decimal? Guessing it's hex. LDA 0, LDA 20. So there's 20. Okay, so it looks like it's hex. And then so it changes after you step past it. '83, store it into 9. So I have a pointer. So I have screen 0 name table. And that is apparently an address 8391. I want to see that just because. So 8391 should be 00381. So 391 would be here, but there's a header. So it bumps down to here. So this is supposed to be our name table. It looks like our name table. Yeah. So that looks right. So where's pointer? The thing I don't quite get is how do I look at RAM values in here? I can set this. That's in pointer. So this is the high byte. No, so it's saying pointer equals 8, but we LDA. Oh, when we skip past it, or we execute that instruction. So there, now it says equals 91. That's great, but I want to see RAM. Figure this out. Memory viewer. Memory tools. CPU memory. Work RAM, I'm guessing that's the 8K byte, no? NES RAM. There it is. This watch window is what I'm confused about. Watch window allows you to evaluate expression and see their value. Yeah, so why does it say pointer value equals 9? Oh, pointer. I think it's byte number 8. Yeah. Or they just have name. Maybe you can't. You can create expressions, but maybe you can't. This isn't the place to view RAM values. It seems like it would be. You'd want to. Seems like a logical place to say, oh, here's a variable. What does it equal? I mean, it tells me right here, I guess. And I can see it anyway. There's some other fancy way, but here we have it. So I believe this is right. That's not right. So I'm using same. Indexed, indirect, and indirect indexed. So Y can do indirect indexed. And X can do indexed indirect. So the difference. Indexed indirect addressing is normally used in conjunction with a table of address held in 0 page. Address of the table is taken from the instruction, and the X register added to it. 0 with 0 page wraparound. So the address in 0 page byte 40 plus X, but it should be byte 40 and the next one. You need a 16-bit address. So index indirect is the most common. Instruction contains the 0 page location of the least significant byte of the 16-bit address. Oh yeah, the address is taken from the instruction with the X register added to it. So that's for addressing the 0 page. Yeah. I think that can. Yeah, address held in 0 page. So that's only good for 0 page. This is the most common. So the instruction contains the 0 page location of the least significant byte of the 16-bit address. The Y register is dynamically added to this value, and that's what we're trying to do. Saying the least significant byte, I'm surprised it doesn't tell us that the most significant byte comes after it. Am I wrong in that? Anyway. The least significant byte of a 16-bit address. Yeah, so it's kind of got to. And that's what I think I'm right. So this points to the base of the name table, and then Y gets added. Okay. So we're going to do 32 rows worth of data. Yeah, it puts it above. Is it? Anyway, so X equals 20. Load Y was 0. So load A with pointer Y, which equals, see, it even tells me, that's great. Which is 0, which I think is right, yeah. Okay, store it in 2007. Nikito, hi bye. Oh, high byte, not high by. It does look like an awesome emulator, and I'm pretty sure it is. I'm learning it as I go here. So why does it say, oh, that was me commenting. That was my comment. Okay. So then increment y, boom, y7, transfer y to a, compare with 20. Branch not equal. So go back here. So y is 20. There's not 20, it's 1. And then which iteration? We should get a fair amount. It's not for another 16 bytes or so. There, E. Oh, no. Oh, actually, I think it's 32. Okay. Oh, I keep loading y with 0. So it keeps doing the same byte over again. Look at that. Yeah, so I making all kinds of dumb mistakes, I'm sure. So let's just look at this again. So our pointer is set up right. We're setting X This doesn't even look like my code. Oh, it's down here. So I hate these shortcuts for branches. I think I can do for a local label, I think you can put an @ sign. Proc cheap local labels must begin with a special symbol, usually the @, but can be changed. Visible only between two non-cheap labels. As soon as a standard symbol is encountered, this may also be a local symbol using the proc. The cheap local symbol goes out of scope. Yeah. So we've got, what did they call it? Standard symbol, set it background. And then like the next labeled, well, there is none, but if we had another subroutine, then it would hit that. So inside this subroutine, we can make as many local labels as we want. So first, the idea we have is we have a pointer pointing to the name table. We increment y to basically effectively increment the pointer. But we're doing the columns first. We're going across doing one row at a time. So y can only increment 256 times. It's going to wrap around again. But my idea is we can increment the pointer after each row. So don't know if I'm using this label at this is start row, next in row, so if we don't reach the end of the row 32, branch to next in row. But I think I need that. Okay. So yeah, and this is why I'm zeroing y, because we get to the end of the row and we need to zero y. But we also need to increment the pointer so that it points to the next row. And that we are not doing. And I think I didn't actually, I wrote this code off stream, I think, so I was testing things out, but so that just jumps back here. So let's do this. Jump next in row. So I'll skip over. So load A with 32, clear carry, add to pointer, and that's the low byte. So branch of carry clear next in row. If the carry is set, then we want to increment the pointer high byte, which is pointer +1. Okay. Clear Y. And do this over again. Now we need some sort of counter to signal when we're done. I was we could use X because we're not using X at all. And I think that's what my plan was, is I was yep. 32, because 30 rows plus attribute name table data, which should follow. I think this is our attribute table data right here. Or here. Yeah. So it's defined afterwards, it appears to follow. So I loaded X with 32. Decrement X. And I'm pretty sure that updates. So 0 flag. So branch if equal or not equal. else we're done. We never actually get to this. Yeah, I don't know. There's the whole point. If we next in row, if we're done, then we do seems backwards. I don't have an RTS at the end, but getting the rust out. Okay. So that counts from 32 down to 0. Once it's 0, I leave. So that'll count from 1 to 32, which should be right. Okay. So maybe we did it. Did something. So it appears we have tile data in there. CHR viewer looks all messed up. Oh, because our palettes are all pink. Oh, apparently overriding them somehow. Looks like our data moved, but it's probably fine. So we do that 32 times. Because we go from that's actually one too many. Because we should be going from 0 to 31. I don't know if that's actually a problem though, but we'd be updating a lot of extra bytes, which might get into palette data. Okay. So load A with 20, clear, increment pointer. Oh, add with carry pointer. I don't actually store it back in. Yeah. So we store the pointer, and then we can just increment the high byte. Okay. I do like this debugger. It's making, kind of what I was wondering is make assembly less obtuse. Easier debugging of stupid things, and I'd like to be better at it. Okay. And then it cycles through. All right, so we fixed 2 bugs. So there's something. It's not going crazy. But everything's still 0. Reset button. Control R. F5. So make sure I'm using these registers right. Okay, PPU adder and data. Two writes, most significant byte, least significant byte, and then data. After reading PPU status, to reset the latch, write the 16-bit VRAM address you want to write to upper byte first. I like how they tell you to reset it, and then they don't actually do it in the code. Anyway, we did that. PPU status is 2002. So reset the latch. high byte first, 20, 2000. And then we write the data to 2007. So Y goes from 0 to 1F. Goes back here. Updates pointer. Branch of carry clear. Next row. Are the resulting addresses from indirect LDA correct? I think it's showing them in the @star. So the address it's set to is 83BB. Well, and it was 20 less than that. I think they're correct because we checked that earlier. It's moving around with each compile, but it's setting them to 3BB, which appears to be here-ish. Yeah. So this looks like set it to 32. This looks like our name tail data. So it looks like it's right. But I wanted to get past, so the first row is all zeros. The second row starts having data. So the first thing we see low should be, it should go 1, 2, 1, 2, 1, 2. Oh, look at that. 2. And we're, oh, but why is, I thought we cleared Y. Oh, that's why. Yep, we skipped over that code. I'm not actually resetting. If the carry is clear, we jump to next in row. Really, we just want to skip. We want to skip over the next instruction. Because then this doesn't, it does 1 byte and Y. Oh, yeah, I see it skipped past it, so that's broken. All right. My labels are terrible and everything, but maybe that was it. Turn this breakpoint off and we should just be able to hit play. Hey, we got something. It's not right. It looks like we're doing 1 less byte than we should be. Everything keeps shifting. So should this be 31 or should this be 32? Increment. Oh, yeah, it is 32 because so in the last one it'll equal 31. We increment it, transfer it to A, and compare it to 31. So if it incremented past 31, then sweet. And the attribute table stuff looks right. We haven't updated the palettes, but the top is one color, palette 0. Awesome. Okay, so let's get the palettes right. We wrote some working assembly. That wasn't too bad, right? Just 3+ hours. Learned a lot, which was the point. Okay. So set up background. So here, turn my little heater on. Without trying to melt any cords. So this is just the example palette. So this is background, sprite, sweet. Yeah, and that I had some bug and I don't know why. The CC65 project where the palettes were getting messed up, we figured it out like stream number 1 or 2. Not having that issue here. I don't know if the palettes are actually what I wanted. What did aren't the palette attributes wrong by 1? Well, so the problem is it looks like it, yeah. The problem is it's actually because tiled. So tiled doesn't, it's a generic background map editor that is not NES specific. So it doesn't have any idea about attribute tables. And it's my own fault, really, because this is, so I started drawing a cloud here on, which is Y value 11. You can see it down here. So I started drawing a cloud, but this has to be the same attribute table as this one. So this is a set of 4. These 4 tiles have to use the same. So last time we've generated the attribute table data based on whatever of that 4 tile 2x2 square was in the top left. So this just happens to be the tile that determines this one's data. So it's kind of annoying because tile doesn't keep track of that, but this was me just being lazy and throwing stuff in here. And one idea I have is to, when we generate the attribute table data, report errors if you break the rules of attribute tables. But anyway, yeah. So it's doing what we said. We just need to make the tools better or draw things within the attribute table rules. Part of the thing is, though, too, is the NES attribute tables are set up like that. Yeah, I checked it all greater than the same palette. But one thing is I changed it, but so the idea with these, so these are the little planks that we walk on, and they're going to be this brown with a gray palette. Well, the bricks below it have to be the same palette, and these are the same tile. So I wouldn't even really want to report an error there. It's intentional. This tile is determining the background, but then I'm like creating rules to say, oh, well, this tile can be any palette. I don't know. The thing that's nice about tiled is you can create stamps of 4 blocks, and as long as you draw them properly, and if I start over from the side and actually keep track of things, it's obvious here that this 5x5 thing is not going to work. Anyway, we'll just kind of see how big of an annoyance it becomes, and go from there. But one thing I wanted, so our idea for the palettes was to have 3 grays. So the bricks here would be, because we basically have 4 grays on the NES, but 2 of them are dark. 0, 0, and 2D are dark, and 1, 0, and 3D are light. But oops. Just want to copy that. This is just one tool's interpretation of it, or palette interpretation, but 10 and 3D look dang near the same. 2D is slightly darker than 0, 0. And that's what I wrote. So darkest is 2D, medium dark is 0, 0, medium light is 1, 0, and then lightest is 3D. So, and I actually loaded one of these ROMs up on my CRT, and they are different grays. I don't know how much it will matter, but I don't know if I actually have screens, the project loading the right grays. So my deal is for the bricks to be medium dark using 0, 0 and 3D. So bricks be using 3D, or not 3D, 2. Yeah, 3D is lightest. So medium dark, I want it to be this one. And then lightest gray, which would be this one. I assigned this little guy to have palette. Yeah, the screen has dirt and drywall, and drywall was going to be the medium gray. Anyway, looks like I actually got some dust on my lens there. Yeah, what now? So we have some assembly working. It's not particularly organized how we want to do anything. Doing Brad's updates, scrolls, and you can reset it with shift. What that was. So part of me says cleaning up the code to not do any of the stuff that hack it down to nothing now that we have something working. As slow as that was, I'm enjoying it more than CC65. And one other thing that I question is debug. Does CC or mesen import labels from ca65, c65, but does my it automatically, so the C that's generated, it does write my code as a comment. And here we go. Set this variable equal to 50. Load 32, jump to subroutine, push A. That's I don't know, that's one of the things that drives me crazy the most, is just the use of routines for variables. This false stack that CC65 creates, as far as I understand. Maybe it's not that bad, but I think I'm going to take a break quick, come back, and maybe just clean up some of the assembly code. I don't know what else to do right now, but I don't want to quit yet, so I'll be back in a second. All right, back going here. So thinking about the next thing we want. Really pretty committed to needing another background tile set for the heads-up display. So instead of gutting everything here, maybe we'll just work towards that, because we'll certainly need it. Right now, the project is NROM. The easiest way right now to get more would be to go to CNROM. So we have 4 background, 4 pattern table sets. but still 32 kbytes of prog. So I think I'll just do that. CNROM is mapper number 3, I believe. So let's see if we can figure out. No. This is these are 2 pattern tables. So that's all there is to it. Other thing I want is a makefile. So I'll use this bat. Steal this super simple makefile I have. Nope, it's the wrong spot. That's like overly simple. I think I have a better one. That's nothing. Yeah. So I'm going to make a a build folder and put everything in there. And copy this. Going on here. So we build it, that's the directory we want to create, and the name of the project. We need flags. Source and object. I don't know if we're going to use this yet. So we'll have a make the build directory. And we want to create an NES file. And then the way that we make that NES file so run think that'll work, but missing separator. Oh. Sweet. Okay. Saying that tiles overflows. Yeah, in the config. Let's just undo these changes quick. Redo them again, but let's see. Example.config. So here CHR is CHR is defined as 0 through 2000. So 4000 would double that. So 8000. It's the same size as the PRG-ROM. They're both 32 KB. So look at that. I think it worked. Let's so compile.nes 65 KB. Yeah. Okay. Let's make our makefile better. So Making a wildcard for any file found in the source directory. So we don't have a oh wait. Yeah. I don't really know enough about the makefile of what I'm doing here. I don't feel like doing this right now. I think we can put it in the build folder though. So create file, build, project, NES, example config, example.o, example map, text, debug file. So now it made a file Alwa debug. Build Alwa NES debugger. Import labels Alwa debug. Good enough for now. Should make a GitLab project too. That's boring though. I'm not getting very far, just doing ancillary work here, but Cannot remove build is a directory. Oh. Yeah, remove. Oh, I think I might need an RF, recursive. What is going on here? Make clean, make. Okay. So we've got a CNROM project, but it doesn't we don't have a bank table which we want because CNROM has bus conflicts. We also don't have multiple backgrounds tile sets yet. Hey Koitsu, how we doing? So we're switching over to assembly. Koitsu. It was a little rough getting started. I'm pretty rusty, but I think I like it. Yeah. So we have all our attribute table data now. We're importing background and attributes into name table attributes into our assembly project. We're converting to CNROM for now so that we can have, we need multiple background multiple palette or pattern tables. So let's make a bank table. And CNROM uses the lower 2 bits to select the bank. Yeah, we've mostly got it already. Just gonna take our mapper one step to the next each time we need something new from it. I don't know if we're gonna end up in MMC3 or some crazy custom thing I create, who knows. But for now we need multiple. We want to get our heads up display showing a different palette set. Yeah, bus conflicts, but it's relatively simple. We don't have prog banking yet. So that's our bank table. So in my setup background, some cold air coming from somewhere. Select first CHR bank. So the trick for that is, so we do like LDX 0 S oh, we just do LDA 0 STA bank table. Oh no, we do want so we want 0. And then we can indirectly, so this should work. If we change this to, or let's do this, transfer, is there tax, right? Transfer A to X. Let's make a subroutine. Yeah, I gotta pay the taxes. It's business taxes are due next week. Super excited about that. Okay, so LDA 0 so on entry A equals the bank that we want, transfer A to X, and then store at address bank table plus X. So that should work. But oh, is storing parameters and registers common practice in ASM? I think so. It's pretty yeah, the stack or WE, what do you mean by WE? It's faster, especially when you don't have a whole lot of them, because so LDA immediate 2 cycles, push accumulator is 3, and pull is 4, so it's like 7 cycles to push and pull when you could just load it in 2, and then in that routine it's already where you want it, or whatever. Yeah, using the registers is, as far as I know, but C creates this argument stack where, but this is the most efficient way of doing it. And then any of your interrupt routines, have to preserve the registers on entry. But anyway, so that should work, and I don't know how well it simulates bus conflicts, but one of our old projects, so this one, patterns save CHR, where did I save that? This. So I'm going to set the heads up display to be the first. My heater down. Heads up display to be the first bank. And Forsaken Valley Sky to be the second. And sweet. So this just happens to be some similar data. It feels like some fan blowing on my face. Anyway, this is just coincidence, but we want, so we have our CHR viewer is here. So we want a Sprite Zero hit to change the bank, the CHR bank. Reminder, don't LDA 2002 in NMI within 2 cycles of the start of it. Oh, yeah. There's a lot of these gotchas that I'm not good at. And I think it's probably fine. So I'm just stealing Brad's example, ca65 example to get started here. Yeah, or here's my Nmi routine. The first thing it does is preserves the registers, because it might be you're interrupting some of their code. So we push A to the stack, transfer X to A, push X, push Y. So these things are happening in the beginning of the Nmi routine. So as long as you do other things, you should be fine. Yeah. And any tips like that, bring them on, because I'm gonna get hit by a lot of that type of stuff. A lot of the Sprite Zero. Okay. Sprites are conventionally numbered 0 to 63. Sprite 0 is controlled by OM addresses. First one's 1, blah, blah, blah. So when the PPU is drawing the picture, when an opaque tile, when an opaque pixel from Sprite 0 overlaps an opaque pixel from the background, this is a Sprite 0 hit. The PPU detects this condition and sets bit 6 of PPU status to 2002. To a 1, starting at this pixel, letting the CPU know how far along the PPU is drawing the picture. Am I right in remembering? Yeah, everything wasn't it. Oh, the NES PPU is plenty fun. I mean, it kind of depends. It's basic. But there's all kinds of things tricks you can pull with it, but it's nuanced. Yeah. I can see why people would say it's not fun. Yeah. It's all about your attitude. So Sprite 0 does not happen if the background or sprite rendering is disabled. At X 0 to 7, the left side of the clipping window is enabled. Any pixel with a background or sprite is transparent. Two-bit color index. Yeah. If Sprite 0 hit has already occurred this frame, bit 6 of PPU status is cleared to 0 at dot 1 of the pre-render line. Okay, that's what I was also wondering is how it gets cleared. So it seems like it handles itself. It clears itself and it sets itself. Sprite 0 hit happens regardless of the following. The sprite priority. Sprite 0 can hit in the background from behind. If the sprites are behind the background, pixel colors only. The CHR pattern of the bits is relevant, not the actual colors. And any CHR color index except 00. Yep. Okay, palette. Contents of the palette are irrelevant. The PAL PPU blanking is on the left and right edges. Overscan. Okay. So, Coach is saying see notes of 2002 for that Sprite 0 bit 6 stuff at the paragraphs is. Sprite Zero hit. Set when a non-zero pixel of Sprite Zero overlaps as non-zero background pixel. Cleared at dot 1 of the pre-render line. So reading the status register will clear bit 7. Once the Sprite Zero hit flag is set, it will not be cleared until the end of the next V blank. If attempting to use this flag for rester timing, it's important to ensure that Sprite Zero hit check happens outside of vertical blank. Yeah. Otherwise, the CPU will leak through and this check will fail. The easiest way to do this is to place an earlier check for bit 6 to be 0, which will wait for the pre-render scan line to begin. Okay. So if using Sprite Zero hit to make a bottom scroll bar below if using Sprite Zero hit to make a bottom scroll bar below the vertical scrolling or free scrolling playfield, be careful to ensure that the tile in the playfield Sprite Zero, yeah, okay. Don't put it on the edges. Okay. Yeah, still shocked by x equals 255. I mean, does it ever reach a point where you can end up doing non-trivial math with your instruction cycles to sync stuff with the PPU? Yeah, my status bar's at the top. So I'm not sure I understand your question there, Nikito. Does it ever reach a point where you end up doing non-trivial math with instruction cycles to sync stuff with the PPU? I don't understand what you're asking. Okay, so what we need to do is anyway, I'm just gonna charge on. So this is our main loop. So let's see. So Brad's main loop. We have some setup here. Draw the cursor. Reads the gamepad. Does a bunch of stuff based on the gamepad. Draw everything and finish the frame. So draw cursor. So here he's based on where the cursor was moved to on the controller inputs, he's updating the OAM data. Yeah, mesen's pretty good. FCUX has a lot of debug features too. I don't know if it is quite as good as far as jumping through the code. If it is, I never figured out how to do that. I didn't realize it existed. To step through the code and everything. I just always logged to a trace file and then read through that. Huge files. So PPU update waits until next NMI. Yeah, oh, I don't know if I missed the good part. I did get my assembly background routine working, so we've converted to CNROM, and now I'm trying to get a Sprite Zero hit. So PPU update. This waits until the next NMI, turns rendering on, if not already, uploads OEM. So this is basically the end. Draw everything and finish the frame. So well, really, okay, so this routine waits until v blank, and when it gets done, then, so when we're coming back from v blank, we're going to go back into this loop. So at this point, we can start stuffing other things in here, but I'm just going to, so v blank, so when we get to this point, PPU update is complete. We may still be in v blank. So we want to detect Sprite Zero hit. I don't care about in this gamepad stuff yet, but so to do that, but we need to make sure we're outside of v blank. Easiest way to do this is place an earlier check for bit 6 equaling 0, which will wait for the pre-render scanline to begin. So ensure we're by so read PPU status. We're checking for bit 6. So we want to make sure it's 0. Yeah. So we'll AND that with 4.0, and then branch if it's equal, then that means it's clear. So branch if not equal. So we're at least past pre-render. Wait for so very similar. Except we're going to branch if equal, right? Because we and it with 4.0, and if it's clear, we'll jump back to check for Sprite Zero hit. Yeah, this is the first time I've implemented it, so it'll be exciting for both of us. It sounds like complicated, but looking at it, it doesn't sound that complex, but we have to actually do it before we comment on how hard it is. All right, so when that happens, we want to set CHR bank. Okay. Oh, but I was gonna do this separately, but yeah, we have to set up Sprite Zero. My idea for now is, as long as this is using Sprite Zero, then I think we can just move his cursor around and get it. I'm not sure. We'll see. So at the when we enter this, we want bank 0 to be selected. That'll give us the heads up display, and then when the Sprite 0 hits, then we have the other bank. So I was going to do this later, but may as well try to do it now. Oh, yeah, good point. See? Not an immediate value. Hopefully that would have spat out an error at me. I am curious. And I want to set these as constants, but I'll just try that for now. So I think that'll work. Oh, I'm curious just to. Yeah. It does give me an error. That's good. Yeah, so the party's trouble wrapping your brain around is the timing of when all to do this. So I think I've got it wrapped around my head, and we'll see how it goes, and And if you're still struggling with that, maybe I can explain what's in my head. If it's right, we'll see. Okay. The one thing I don't know though is setting up the actual Sprite Zero hit. So 4 sprites centered around, let's currently select a tile. So it looks like he is using Sprite Zero. I don't know if it's... Let's look at... So where is... It's got 0 page. Then in the BSS we got 256 bytes of a buffer. Yeah, the config file. Yeah, 100. Doesn't look like it though. Wait, hold on a second. Align to 100. Yeah, 200. Yep. Okay. So here's OAM, and then let's. So byte 0 is the Y position. Byte 1 is the index number. The tile number of the top sprite in the bank. So he's got 01. So it should be tile number 0 in the second bank, which, see, I think it's all transparent, which would be no good. Oh no, tile number 1. Yeah. Or wait. So the tile number of the sprite, 0 to 255, the bottom half gets the next tile. Oh, that's for 8x16 sprites. Yeah. So it's using sprite number 1. And there's non-opaque. So as long as I overlap, I think it'll be good. So it's using the something's not. My is it the debugger that's... I never quite understand if it's running or not. It's not moving. Why not? So it is running. I break my cursor check. Yeah, do we set up an infinite loop? Oh, because we're checking for a Sprite Zero hit, which never happens, and so it sits there forever. Yeah, so at some point we need to give up. Unless it just always happened. So let's try to initialize. Let's just force. I was gonna move the cursor, but we. Oh. Yeah, cursor starting positions. So if we, as long as we know the Sprite Zero hit's gonna happen, we don't really care about the infinite loop situation. So main starts out with the cursor centered. Uh, 128, 120. So so we'll say y of 1. I think that'll work. There, it's up there. But that's it's like off screen. Yeah, maybe. So it looks like it's overlapping. I don't have an infinite loop, but there, I created one because I moved it. Control R. So we don't have an infinite loop. We should have a Sprite Zero hit happening. Yeah. The Sprite Zero hit's happening, but it doesn't look like our bank switch is happening. Let's make sure that I actually have the bank set up properly. So we have the heads up display. Yeah, and we should be able to. To some degree, it's kind of helpful right now to know that we created that infinite loop because it is based on the cursor. If we wouldn't have had that feedback, we might have been scratching our heads. So we know that the Sprite Zero is happening because we don't have that infinite loop condition. See right there, I moved it over and we created the infinite loop. So so we have our infinite loop, but the problem is we're not getting our bank switch. Yeah, I was messing with the makefile earlier and I got bored and didn't want to work on the makefile anymore. Yeah, okay, good, because I know enough about makefiles to get myself in trouble, and that's about it, but they're boring. Yeah, so let's see here. Let's set a breakpoint on set CHR and just make sure that oh, watch CHR banks and mesen. I'm on CHR viewer. The stuff at the bottom debugger represents that. Oh. So I think this is saying bank 0 is selected. That was, so there's also an event viewer which can tell you. Anyway, I'm gonna stick with what I know for now, including how come it's not? Auto load. Why don't you do that? Anyway, set CHR bank. Why won't it create a bank table? Or a breakpoint? Oh, I need to do it on the actual instruction, not the break, not the label. Okay. So we hit it. A equals 0. Yeah. A equals 0. Bank table equals 0. That looks good. Return subroutine. Run. A equals 1. Store at bank table X, which also equals 1. Return subroutine. So, oh, wait a second. Yeah. I'm waiting. What do we do? Now it's 0 again. Do we immediately, well, the bus conflict thing, the bank numbers have to be at the top of the bank. No, like offsets. The bank numbers have to be at the top of the bank. Yeah, so bank table is 839D, and if we look at my, I think it's good because mesen is telling me when I execute it that what that address is actually at, but it's, so bank table is 839D. So 39D is here, but we have a 8, oh no, not 3, 83. 839. What am I? Oh no, not the 8. It's just it's just a destination address, and I'm remembering wrong. Remodified right. Yeah, maybe because 39D is my actual bank table here. 39. Here it is. Yep. 39D is here plus the header. So here's our bank table, and when it executes, it tells me that that address is equal to 0. X is 0. That address is 0. Great. If we run, so we can run for one scan line. Yeah, it should show it changing down here. Well, it's 0 right now. I was trying to run for one scan line. Okay, I got past it. Check for Sprite Zero, so A equals 1 on the entry. Bank is still 0. tells me that bank table X equals 1, which is right. So we're writing 1 to a value of 1. And why doesn't it happen? Am I not telling mesen that this is CNROM or something like that? Yeah, it should be right. The flag is set to 3. Where it is tools log viewer. Log window. Mapper 3, sub 3. Oh, well, what? Why does it say the program? See, oh. Here's the problem. I didn't change my header. I gave it all the data, the files there, but the header says that it's 8 kbytes. That needs to be, so this is count of 8. So 2 would be 16, 3, 4. Okay. Good call on this, though. All right. Mesen just like does everything you could ever want. Turn this guy off. Oh, okay. Okay, it's working. Now we just need to actually, yeah, it's the emulator we always wanted back in the 90s, yeah. Okay, so it's working now. The only problem is our Sprite Zero isn't in the right location. So we want to move it down. Uh, 1, 2, 3, so 3 times. So I think we want it like, yeah, we should. I want to see it work though. Run. Okay, move down a little more. This is exactly. Oh, can we just move it? Can we just move it? Hey, look at that. Okay, it's right about here, so it's switching the bank. But we got it. Oh, I wasn't expecting to get that so quickly. Yeah, so we have 2 different banks operating. So did you had a saying, Kwitsu, that you're curious as far to how went the timing of everything, and so I was talking through that a little bit earlier. So I'll just kind of recap here. So I was just this is our main loop here. And here's our infinite loop. So when NMI starts, and yeah, okay. So here's what here's our infinite loop here. And this is again just this is Brad Smith's ca65 example, but in his infinite loop, the first thing he was doing, we inserted our code here. The first thing he was doing was reading the gamepad. Then he does different things based on what's being pressed and everything. And then draw everything. So he has a subroutine for draw cursor, which just updates the OAM so that it's ready for next VBlank, and then PPU update. So this PPU update routine, it waits for the next NMI. So he's calling this at the end of the end of our main loop. And it basically hangs and waits there until NMI happens, right? And then it does some things. So it turns it on. If it's not, uploads OAM. And so this, yeah. So this code is happening. I don't know how I was looking at it before, but anyway, because this actual Nmi routine, yeah, he's got a lock and ready. So the oops. PPU update is it's communicating to the NMI, lets it know that it's ready, and then the NMI only does things if NMI is ready. All this routine is really doing is communicating to the NMI, but once, and then the NMI communicates back, right? So in the main, once NMI is once the NMI handler is done, then we return back to the main and end up back in our infinite loop. So we know at the beginning of this that PP update's complete, but we could still be in update, and then that's when we do our stuff. We select CHR-0. We wait for the pre-render so that we know we're out of NMI. We wait for our Sprite Zero hit. Yeah, it's basically a wait routine at the end of our loop, our main loop, so that we only execute the main loop once per frame. Yeah. Yeah. So that wasn't half bad. What we should do is create a more permanent Sprite Zero. So the thing is all of Brad's OAM stuff is hard coded. So he's this is the only place when he's yeah, so I think we'll have this, we'll just hack this. The first one to be a Sprite 4. So I think I've moved it to Sprite. The cursor is no longer using Sprite Zero. Yeah, I don't know what you missed, but if you want me to... I'm not dropping any frames. So hopefully it's not me. Okay. So we moving the cursor to use sprites 1 through 4. So what I want to do is I want to put the Sprite Zero to basically hit right over here at the end of this boundary. Trying to think. Yeah, you might be too far away, Ben Shaku. You need to come to the States. No, stay in Japan for now. You're doing good work over there for us. All right. So I need to come to Japan one of these days. See, look, we can move the split. So basically what I want is I want a sprite that basically just looks like it's just a line, really, or it really needs a dot. Yeah. Your card? No, I haven't seen it. Let's look at open CHR. Sprite. So white is this index. I'm just going to draw a line. That way, hopefully, if we mess things up, it'll be easier to find. But my idea is to have this sprite basically be here, and then the bank switch will happen. Okay, we need to place that So it should be, because this is 3 high, but we got the first one, and yeah, then the switch would happen in H blank. And we might have to move the X position. Tweak it to get it to happen at the right time. The other thing is we might be able to have some of this tile matching between, but hopefully we can fiddle with it. That's quite the jitter, but we'll see. The other thing is I think I might have a row of black. If I have one scan line that's black, maybe. So here's the issue. I have these tiles, so my opaque Sprite Zero hits can happen here in this corner, but then we have another scan line where we still need this tile set. Not necessarily this tile set, but a tile set where anytime it draws one of these bottom guys, which is these 3 tiles, it's opaque, or I'm sorry, it's transparent. And that's probably not true in our Forsaken Valley tile set. There's stuff here. But if we picked tiles that are comparable, so like these ones down here, they're black on that bottom line. Same thing with our bricks. Our bricks are black on that bottom line. So if the heads-up display used the same tile numbers as like these 3 guys, then it's all transparent. You can swap out that tile at pretty much any time during that scan line, and because the pixels that we care about don't matter anymore, they've already been drawn, we're swapping transparent pixels for transparent pixels when we bank switch, and so that timing is less critical then. It just have to happen after. So maybe we'll get it working first and then move the tiles around. So the position yeah. So more like that, because because we have, this is really what the tile kind of looks like. We'll put it like right there. And so that should be, let's look at the Y position. Byte 0 is the Y position of the top of the sprite. Sprite data is delayed by 1 scan line. You must subtract 1 from the sprite's Y coordinate before writing it here. It's delayed by 1 scan line, so sprites are never displayed on the first line of the picture. Yeah, it's impossible to place it at. So if we want it to be 4 tiles down, because 1, 2, 3, 4. 4 times 8, 24, but you're supposed to subtract 1 because it's delayed a line, so it should be 23, which looks about right because I think that was the number that we wrote. This sprite looks like it's aligned. Oh, yeah. Like I said, I can't do math on stream. That's why you guys are here. 31. We have it at 24 right now. So maybe, but remember we couldn't have it at the top. I don't know. 24 seems right. Well, hold on a second. I'll look at this again. So this bottom, this is actually down 1. So it looks like I was right with 23, but not because of my math, because some misunderstanding made up for something else. So 23, because if you look at this sprite right here, it's actually down 1 scan line from what we want. Yeah, so set its, we want the Y to equal 23. So OAM LDA 23. We wanted to use so that's byte 0. Byte 1 is index number. We want it to be 0. Byte 2 is the attributes. So this will probably change in the future, but anyway, we're going to use palette number 3. Oh, and this is actually nice. Because we can set it in the background, we can set this sprite behind the background, so if the palette colors don't match up between the sprites and the background, we won't see it. And we don't want to flip it. We'll put it in the front for now. So we want byte number 2 to be set to 3. Yeah, that bit. That's why Mario gets behind the background when you hide on the white blocks, or push down on the white blocks, I think. And then byte number 3, the X position of the left side of the sprite. So we had it centered at yeah, a lot of fancy things work that way. Or like have your player go behind the background when they crawl in a cave or something. So we don't want it. X scroll values of F9 through FF results in parts of the sprite to be past the right edge of the screen, thus invisible. So let's just set it to F0. Foot adjusting my heater here. Okay. Don't see our sprite. Did I get the yeah, it's there. Oh, it's on the wrong. I guess I didn't save my still don't think that's the issue though. I'm actually going to make it all white for now. I don't know if I... Sprite viewer. So I messed something up. Where is... It says that it's tile number 0. The position is 0255. Oh, is... It's right here. Did we mess up the attribute somehow? That's what exactly what we wrote to it. Oh. I wonder if... Did we create our infinite loop situation? But we... Let's see. So it lets you look at OAM. I mean, this is basically OAM then, right? It's saying that it's not Sprite index 0. It's because remember we were looking for this before. So it's right there. We're setting OAM properly, it appears. Because I can't move the cursor, I think we're in the infinite loop situation. So let's do this. Let's just oops. Let's comment out our there's our sprite. It looks right. I think yeah, it's sitting right there. Just like we want it. It's all white. But we create this infinite loop, and in doing so, I think we never get to PPU update, and PPU update is what's actually telling the NMI to copy over the sprites. And so we're updating our OAM buffer in RAM, but we're never telling the NMI to copy it over because we get stuck in this infinite loop. So do we have to skip it the first frame or only? What am I doing wrong here? So I think what we want to do is actually set our Sprite Zero hit up here. Where am I doing it? Oh, right after the PP update. Boom. Order matters. Okay. Yeah, my phone told me there was a problem with this channel. Because I'm like kind of watching myself on the phone, just the chat. So, I don't know. Might be my Comcast charter, whatever. They're all the same, right? It's all Big Brother. So I got it fixed. Problem was we created the infinite loop and we never got to the PPU update call at the end of the main loop, which actually told NMI to copy things over. So we just have to set up that Sprite Zero before the infinite loop in the main init. Yeah. So all I did was move this code right above the PP up. So we draw the cursor, we set up the Sprite Zero where we want it, then we call update. NMI will update OAM, and then when we come back, we don't have an infinite loop because our Sprite Zero hit will actually happen. Yeah, it hadn't run because we were waiting. Anyway, yep, that's what happened. So it looks like we have the position and everything correct. Now we have this issue where this is drawing the bottom of the vines because if you look at these top rows here, it's all these vines. And if we look at the heads up display, it's these three tiles right here. So the easiest solution for that is to have the bricks be using the same location, and that would get rid of that. I don't know how much longer I'm going to go here. Let's do this though. So we got it all working. Let's change this back so it's just a line. And we'll actually so now it's just a line. It's in front. We can change it to the back by setting bit number 5. So 2, 3. There, we can't see it. Part of me likes seeing it though. But if the colors are the same, then you're not gonna see it anyway. But it's informational. Anyway, we did some things. One thing that somebody was mentioning to me is they're interested in kind of keeping up with where I'm at with things, but watching 3+ hours on YouTube, obviously, most people have better things to do with their time. So I might kind of, at the end of the stream, do a quick recap to say everything that we did, and it would be interesting not just having these recaps for right now, but you know, when we're like done, you know, there'd be like, I don't know, maybe an hour or two, however long it is, a more comprehensible thing where I could just quick slap all those clips together and here's making it in a matter of an hour or two. So let's do that. So this is a recap of stream number 8. Today we started off by brushing some of the dust off of assembly code. We fixed our routine to set up the background to import the background data. We also fixed our issues with loading labels for the mesen's debugger. I think it's just my version of ca65 that was causing issues. So we fixed that, and we had a working ca65 project assembly that loaded our background from our dummy tiled example. Once we had that working, we set up our Sprite Zero hit. We did make a dumb little makefile, so we don't have to use the bat file, but it's not that good. I'm not going to show you. So we're switched over to CNROM mapper. So CNROM is similar to NROM in that it only has 32 kbytes of PRG-ROM instruction data for the CPU, but it adds extra banks of CHR. Because we're using so many tiles in our background, we want to maximize our tile count for the background, and we also need a heads-up display, or at least we want one. And this heads-up display would consume a number of tiles. Right now it's fairly empty, but things will get entered there, and that could take up several, maybe 20-30% of our tiles. And so we implemented a Sprite Zero hit, so we switch the background tile set. Now we have 4 tile sets to work with the basic CNROM. So at the beginning of So for our infinite loop, at the beginning of our infinite loop, we have we select the heads-up display bank, which is CHR bank 0. You can see that in our CHR viewer. This is what our bank 0 looks like. I don't know how to select. Oh, and here is our bank number 1. So the heads-up display, when the frame's rendering, we start with bank 0. Then we wait for the pre-render scan line to ensure that we're outside of VBlank by checking the sprite 0 hit is clear. Once it's clear, we know that we're at the pre-render scan line, we're outside of VBlank. Then we're waiting for the Sprite 0 hit to occur. So Sprite 0 hit is when the very first sprite, sprite number 0, has a color that's not transparent. So not index number 0, overlapping a background that is a background tile or a pixel from the background that's also non-transparent. And so you can kind of see that here. We set up, here you can see the sprite. We put it right at this location. We started off, it was tied to the cursor. We got that working, and then we moved it over to this one sprite. So once the code gets to that point, we poll looking for bit 6 of 2002 to be set, and then we set CHR bank to 1. So we'll switch. This is the heads-up display CHR bank, and then we switch to this one. And so then we start seeing our background, our Forsaken Valley tile set. Right now you can actually see there's this scan line that's messed up basically. We have a plan to fix that, but what's happening is these tiles are getting drawn and the bottom of these tiles is black. Well, when the bank switch happens, boom, it's these same tile locations. We're seeing at bottom of the vines there. So we're going to align those with these bricks or something like that so that it's all black. Yeah, and so that's what we did for stream number 8. Anybody in the chat have any questions or anything? I think we're gonna sign off for the night. Thanks everybody for tuning in, and you guys have a good rest of your week, and we'll see you guys next time.